Hello friends. Last time we have started the session for the move instruction, and we have shown how important to understand and take the usage of the move instruction to move all kind of data and different type of data from the source to destination, and how to utilize this in your program to solve numerous of problems that we might face to move the data from one variable to one variable, one data type to other data type, or a massive move to move the massive amount of data or data block with the option of selecting the number of items to just be moved. And today we come with the a masked move. So what's the difference between move and masked move? So move meaning move with no restriction, like when I use the instruction to move data from source to destination, so all data will be moved from source to destination. But in masked move, there is a facility or additional option to make a mask to control the data to be moved or don't move to between the source and destination. So let's see today how we can implement the masked move. So you can see here in the screen the destination before the masked move, which is called in Allen Bradley MVM masked move instruction. So this is the destination, source, and mask. So you can see the source here is the second row. So this is the source and this is the destination. So when you see the source and destination, you will find a difference. Not all bits typically transferred from source to destination. What's the reason? Yes, the reason because we use a mask here. So if the mask is 0, that means the move instruction will not proceed or will not be effective for these bits. But if it is on, that means go ahead and move from source to destination. So this is very important because you can imagine if you have for this stream of bits like you have dozens of outputs. You control the outputs by the condition of the inputs or the condition of the whatever you want to run your output based on. So you can make this like for each single output or for each single bit you can make a complete run or a complete line of code. So you can imagine if you have 100 of output and you want to use the move instruction to to use the conventional way to activate or de-energize this outputs. So you will have a very lengthy program. So that's why we use the move instruction to move all the data at once. Like you have, for example, input routine, and once you get this input routine, and then you have a process routine, and then you have output routine to move the result of the processing of input to the output in just move in the output routine. So this is a very organized way to program your code in a ladder logic. And also we have been introducing the masked move to make the control to say, oh, with some restriction or some condition, don't proceed to move the result to the output because there is a restriction or there is a condition here. So that's why we showing you today the merit of using the masked move. So after explaining the masked move theoretically and by image example here, so we wanted to simulate this together as we used to do every time to make the information clear to you and to enjoy together to practice our programming session. So here, let's open our simulation. So now we opened our simulation here. So let's see, like this is will be the sometimes the this is the trigger for the move. Let it be like, for example, it will be a input uh, 0, okay, 0 0. So and here the mask. So the move mask will be in the group of move data. So we have here move and MVM, the masked move. So let's try first the move instruction. So I want to move the let's see here, simulator for the IO simulator here. So we have here the IO simulator, and I want to move all the input from input 1. Okay, so I want to move all input from input 1 to output 2, which will be auto. Okay, so I want to move all this data from here to there by having this input. So let's see this. I'm sorry. Let's see. This is about input 3 to be a different raw data. So here, let's go for simulating this code, downloading and simulating, and see if I have this is a source. So my source here showing this data, and this is the input to activate this thing. So I need you just to activate this one. So 0, I think that means this is a problem in the simulation. So here the amount. So I just want to this is the input 1, and I will use this one to here to be moved from I0 to I13 to this one. It will be auto 0. So if I take this one auto 0 here to here, okay. Yeah, it's like let's see here, download and see if the app is going on. Like if I move this one, okay. So here, like I'm saying, this is the trigger for the move, and here in the move, I'm saying the source will be all the input number 3 and the output number 4. So once I triggered this one, so any data of the input will be moved to the output. As you can see, all data will be moved without any restriction. So this is the way of the move instruction from here to there, and this is the destination and the source, as you can see. However, you changing all your changing in the input will be reflected or moved to the output buffer, as you can see. So that's very simple. So how about using the mask moved to see the difference between here and there? So it's very easy here to make another way. Like we'll keep this rung as it is and make another move here for the second rung, but it will be not move, it will be masked move like this one. So I'm using this masked move here, and this masked move I need a bit instruction to run this one here. So I just want to take this one here, no need for this one. So this is a masked move, and in the masked move, to show the difference, I will use same addressing. So this is the input, and this is I mean the source, and the output or the destination will be O2, as you can see. But I will use a mask, and the mask here will be, for example, will be I don't know if I have another input or not. So input, I think input 5. I think I can work with input 5. So I don't have input 5 here, or so I will use the input 1 as a mask, right? So I will use the mask here to be input 1 as a mask. I'm sorry. So input 1 to be as a mask, and see what's going on here. So let's see here what's going on by downloading this program and running the program and see. So here for the first one, this is for triggering the work. Oh, I missed to put here. This is the trigger also will be on 0. So here downloading and see. So both of them are triggered, but I won't see what's going on here. So if I trigger, and as you can see, all data will move to the output 2, but nothing moved to oh, I need this to other destination. That's good to miss something, because missing this thing like make you understand everything and be more familiar with what's going on. So I use this output for the move, and this output for the masked move. So let's download this thing again and see what's going on here. So so you can see here the output here, all the data from I3 moved to to output 2 or O2 because there is no restriction or mask, but here no data moved else the first one. Why? Yeah, that's very correct, because the mask. So whatever you have in the masked bit, it will be like a control. So all data will be moved in one condition. For mask, for move, no mask. So all data will be moved from I3 to O2. But there is a condition in a masked move to move data from I3 to O4 based on the I1. So if I1 all are true, so it will be same like the move. Like, see, all data now moved from here to there. But if you make a condition including in the mask, so in this case, based on this mask, the data will be moved on or off. Okay. Thank you for watching, and I hope you enjoy my session, and let's meet next time to explore more and more of the ladder logic programming visually and in our video session together, and practice every time in our lab and simulation. Thank you for watching and following me up until this point of our session, and let's meet next time. Thank you and have a good day. Bye bye.